this works, great. If it doesn't, I'm not going to fight it. All right, cool. All right, got that working. Cool, so we'll be covering Spring, MVC, and controllers, and then some definitions that we can kind of start off with for building context. Spring is a framework for building Java applications, which, among other things, includes tools for building web applications. So when we talk about Spring, we are very much interested in its ability to build web applications. MVC, Model View Controller, is a design pattern for building applications. It's not necessarily a library or a bunch of syntax that we're going to need to learn. It's just conceptual, and then a lot of the things that we will be learning fit into the MVC concept. And then finally, we have controllers, and controllers will run code when traffic is received at a specific URL. Controllers will respond to the request it receives at a URL. So traffic goes to an endpoint, a URL. The controller latches onto the traffic, I guess. It acknowledges the traffic. It might run some code, and then it will send a response back. So it receives, and then it responds. Controllers never go the other way around. We can talk about this more later. A controller doesn't send and then receive. It's always like waiting for an input. You can imagine if you press a button on a website, that fires off an event listener, and then the code runs. A controller, especially when it comes to this whole web side of things, it's only going to, it's like pressing a button, then the controller does its thing. You send traffic to a URL, the controller does its thing. So kind of getting ahead of myself there, but that's hopefully a little bit helpful. Cool, so we'll talk about Spring for a moment. We will be using the Spring framework to build web applications using Java. To get started with Java Spring, we'll be using the Spring initializer, misspelled, which I feel like kind of dates it to 2007-ish, maybe. Anyways, when you use a Spring initializer, it will generate a basic Spring project and take care of a bunch of configurations. So it's doing a lot of the not fun work for us. If you have not, and I have a good feeling that many of you have, or at least partially have, completed the chapter related to this lesson, it is unskippable in my opinion. There's just so much must-know information in the chapter related to this class that if you haven't fully completed it, I really encourage you to make time for that soon. Cool, so I was going through the workbook trying to prepare for this, and I noticed when following the directions for the Spring initializer, it didn't tell us the version to choose. Instead, it gave some general guidelines of which version to choose. So something like for Spring Boot is the newest version that's not a snapshot. Well, the newest version, 3, isn't very compatible with Java 11. And so my recommendation is to choose 2.7.10, that version right there. Choosing that version, I didn't have any issues with that. Also, a quick comment on graded assignment 3. If you haven't already looked at it, it is essentially taking the job app thing that we built for graded assignment 2, and it is converting it into a Spring app. So all of this is going to be very relevant as we do graded assignment 3. Also, this other comment in here, after LC, or not LC 101, after part-time web dev, this curriculum, we go through Java. After that is the job readiness portion, the liftoff, and I'm not really sure what the details will look like this time around, but typically y'all will build projects, and oftentimes, because we've just learned all these great tools, it'll be written in something like Java Spring. And so it's very likely that you'll use this again when building an application that you could show off to potential employers. Okay. I'll do a quick pause here for questions regarding Spring in general, or the 10 other things I kind of briefly covered. Any questions, thoughts, comments before we continue? Yes.
You should maybe compare and contrast with Angular, Spring and Angular, like to what extent do they cover same ground? Like you're making depending on website, would you choose one over another?
That's a great question. So yeah, that's a really good question. The question was, can I compare the Spring framework with the Angular framework? And when you choose one over the other. So the Angular framework is going to be a framework that covers the V in MVC. It's the view. And so we would use that for our front end, the part that the users are interacting with. It's basically, it's a bunch of code that does boil down to JavaScript, HTML, and CSS. And so, yeah, it's like for a website would be Angular. Now, Java, on the other hand, is something that cannot run in a web browser, right? We can run it on a computer. We can run it on a server, but we can't run it in a browser. So the Java Spring has a different set of things that it's going to be used for. So if you have, we'll talk about APIs briefly, but if you think about a website that, let's say you build a website and its one job is to display weather information. So you take in the user's zip code and you display what the weather is. So you're probably going to ping an application interface, not a website, an application interface, and it's going to send you back data that you then make pretty in your website. And so this whole API, this application interface, would be a good use case for something like Java Spring. With Java Spring, we can build an entire application front to back. So what I mean by that is we could build something where Java is from the server is providing the view, the HTML, CSS, and even JavaScript to the browser. So for example, like if you go to localhost 8080/index HTML, something like that, or /home, the controller will provide a website. Java can also handle talking to a database. You can't do that with a front-end website. And so the worlds that these things live in are two different worlds. Angular is something that is essentially going to run in a browser. Java is something that is going to have to run on a computer, on a server. It's a lot more like you can think of it like a desktop application. And so I think it's hopefully I'm explaining it enough to build a bit of context, but I know I'm not able to paint the entire picture because there's lots to cover. Is that a bit helpful, or do you have clarifying questions based off that explanation?
No.
Neither helpful nor clarifying questions.
Yeah, I don't have any clarifying questions.
Right.
I mean, it seems like we are building the front end, so that's why it's not clear why, because like the projects that we're doing for the studio, we're able to interact in the browser with it.
Yeah. So let me maybe try a different angle. Let's say I was wanting to build an application and I had the option of doing everything with Java or doing some things with Java and some things with Angular. I would choose to do some things with Java and some things with Angular. And so I would probably build a web app using both Angular and Java Spring. And what I would opt to do would be to have my Java app only deal with data. So, and then my Angular app would take in that data that my Java app is handling, and it would display it and do all the things I want it to. Now, technically, and so that would be this sort of pattern we see right here. We have a standalone UI, maybe written in Angular, and then we have the application interface, which is also running and accessible from the internet just through back channels. And then, of course, that has to be wired to a database. And so this would be like you have two separate running applications, the UI and the application interface. How we will be doing it in this class is we will be building everything in one. So the Java app will also be rendering the HTML and the CSS and stuff. And so we won't have access to like all the great features of Angular. We'll kind of be restricted to what we're able to do with time leaf, which is something we'll be learning about later. And so the Java app will basically be doing everything. So this is what we'll be doing. It works great. It's really good for getting something up and running within a constrained amount of time. This would be something more ideal where we would have Java handle just strictly data stuff, which it's really good at, and have the UI handle everything else as far as the visualization goes. Yeah. So it's a long-winded answer. In general, I would say that Java Spring is better at making a REST API than it is at making like a user interface. And Angular can only make a user interface, so I would choose both. Yeah. Sweet. It's a good question. It's definitely difficult to really cover that question properly because you end up in so much in a lot of different territory when it comes to like contextual knowledge. Cool. Other questions? Other follow-up questions to that? No. All right. So MVC. Sometimes I have a hard time enunciating each of those letters, but it's a design pattern. In my opinion, we don't need to necessarily spend a ton of energy trying to understand this up front. We will build context into what MVC is as we go through this course. So as like a light overview, the M in MVC is the model. And so the model is the shape of the data. It's basically everything, all of your classes that define your data structure, your fields and things like that. That falls under the category of your model. And so your model is going to be wired to your database way later on. It's all about the structure of the data. The view is what the user interacts with. It's the view is what's visible. You can think of it that way. And then finally, the controller, what we'll be talking about here, is essentially the go-between between the view and the data, the model. And so we'll talk about this more, but it is sort of like the in-between entity. So in my opinion, this should be VCM because I think in terms of like you have the view, it talks to the controller, which talks to the model. But we'll get to that. So I'm going to skip past. Okay, no, this is good. So this is an example. Let's say a user posts a comment on an Instagram post. So what's the model's responsibility in this scenario? The model is going to define the data structure. So it's going to define what a comment looks like from the data side. So a comment is going to have something like an ID, a user ID, a post ID, a comment string, and then probably like a date timestamp, something like that. And so the model is going to define that. The view's responsibility in this user posts a comment scenario is that the view will be responsible for displaying one, existing comments, and two, it's going to allow the user to type in a comment and press post. Finally, the controller will receive the comment from the view. So the user press post, it gets sent off to the controller. It will receive that, and then it will send it to the model. It will kind of work as like this in between. So here's a way to visualize it, hopefully. So we have an Instagram post right here. Someone types in a comment, the press post, that gets sent to our controller. The controller, this is just some lightweight code, it's missing some details. The controller takes in that code and then it saves it to the database, which it sends it to the model, and the model is structured like this. It has a post ID, it's text, it's an author. And so that would be the general flow. The part of the flow that's more relevant for this evening is just thinking about maybe how the view would talk to the controller. So let's not worry about the model so much right now. So here we have an example where someone pressed post, and then it sends off this HTTP request. And the HTTP request looks something like this. You've got Instagram.com, because this is the app that we're dealing with. It's got a path variable of 1 that associates it with the Instagram post, / comments, and then the content body of this HTTP request has the comment in there. And so that hits the controller, and the controller basically does run some logic once it receives it. So press post, triggers something in the back end, the controller then responds. Looking at these two slides right here, any questions or clarifications that you'd like to ask? No? All right, moving forward. So that brings us to controllers. So big scale MVC, not just the C. So like kind of mentioned before, the controller is going to receive traffic, aka a request. So you'll hear them talked about as being requests at a URL, and then it will return a response to the sender. So another example would be a human or a computer makes a request to this URL, localhost 3000/random joke. Let's say this is our app, and so we have a controller that receives the request. So we haven't done anything yet, but we have a controller that captures the traffic at random joke. And then once we do that, we go ahead and fetch a random joke from our database, or from maybe just an array of jokes. And then we'll respond with the random joke. So we'll return that from our controller. Quick comment here. I want to kind of connect wire something from Unit 1 to Unit 2. So here in this example, I said a human or a computer makes a request to this endpoint. You want to think really hard and think about Unit 1. When we use JavaScript to make requests to endpoints, does anyone remember what that method or that function was called that we use to use JavaScript to make a request to an endpoint? Fetch. Thank you. Yes. So in Unit 1, we used JavaScript. We had fetch, and we basically just pass in the URL, and our code would then request data. That's a very important thing to have in the back of our minds, that we can actually do that. And so a human or a computer makes a request to this endpoint. Here, so yeah, HTTP request might get sent to youtube.com. youtube.com will provide like the HTML for their website for the initial load. If you go to catfact.ninja//fact, it will provide you with JSON data. So this is not a website. This is more data for a website to use. So what you should hopefully think of when it comes to JSON data, at least not hopefully think of, but that would be a good way to think of it. And then finally, we have this URL, localhost 8080/hello. And there is nothing there. If you go to that on my computer, it's not going to give you anything. And so we're going to need to solve that problem soon. We will do that. And so the way we'd solve that problem is we would, for our locally hosted application, we would write a controller that controls traffic at /hello. And we can have our controller do whatever we want. So let's go ahead and do that. Right, so here we have our controller. Let me see, there's like Alt-Shift period, there we go. And so we have this get mapping annotation. And so let me actually scale back one more step. We have a class, and the class name is hello. It doesn't matter a whole lot in this context. We can name it whatever we like. But we have this very important annotation up here that says controller. And the controller is basically saying, like, this class is not a normal class. This is a special class that handles like web traffic. And so inside of this class, we can put all kinds of different methods in here that do the actual hands-on dealing with the traffic. So anyways, we got this controller thing that says this is a very special class for web traffic. And then now we have our method that is managing get requests to hello. So quick pause here. I'm actually going to ask y'all a question. Feel free to raise your hand for this one. What, in your words, how would you define what a get request is? What is the get method used for, as opposed to post, delete, put, etc.?
I remember that Git was one of the main two ways that we can grab data, and that, if I recall correctly, it uses or reveals itself in the URL. If I remember correctly, it was considered less secure than Post.
So you're definitely like 98% there. So right, so get is like the most common way that these requests are sent. It's not so much a security thing, unless you really get into the weeds on some other stuff, which we don't need to do. So a GET request, for context, if you are in a web browser and you navigate to any website, your web browser makes a GET request to that website. And then when you load the web page, that is a GET that's loaded from a GET request. So just typing in, let's see. So if I just go to CodePen and press enter, it sent a GET request, and I can show us that that was in fact a GET request. Let's see here. I'm just going to preserve the log. There's going to be a lot of other things that happen in the background. But the very first thing when I refresh the page is we have a the very first thing is hopefully you can see this, a GET request to the website URL. Right, so browsers are making GET requests all the time for us when we go to a website. And it's the only type of request a browser can make. A browser can only make GET requests. And so all of these other types of requests, like post requests, delete requests, those are all handled by JavaScript. So the browser makes a GET request, loads up the website, and then the JavaScript will send out a bunch of requests after the fact. And we'll jump back into that concept here in a moment. So generally speaking, a GET request is going to get data. It's going to retrieve data. It's just asking, hey, can you send me some information? And so we have a GET endpoint. Sorry for jumping around, got lost. So we have a GET endpoint here, and we want it to return some data. And so I'm going to try and say, well, let's just say hello, exclamation mark. And make sure I run the right thing. So this is also worth mentioning. So I can't just run the class like normal. Instead, what I'll do is, maybe I could, but I'll select Gradle over here. I'll expand tasks, I'll expand application, and I'll double click boot run. So that's kind of how we get there. Right, so now that this is running, it is running at localhost 8080, I believe. So we will go to localhost 8080, and it doesn't give me a 404. It gives me this white label error page. Well, technically, yeah, this is a 404, but this is good news. This is coming from our Java app, so at least something's there. The endpoint I just edited was hello, but there's still nothing there at hello. So my code is broken. I gotta close this. Stop clicking on VS Code. My code is broken, and it's missing something. Can someone tell me what is my code missing here? I think I set it up all correctly.
Missing the response body?
Correct. So I'm missing the response body, and this is an annotation that basically says that it should include this in the response. So let me show you what that looks like. So I'm going to refresh, and now I have successfully returned some data. And technically, I can do whatever I want in my controller. I could not really return any data, but I could say, I could do some logging in the background. And so if I refresh here, I don't know how buried it's going to be. Yeah, here we go. So I don't return anything now. This is an empty page, but I'm tracking the fact that someone visited it. So I can do whatever really I want to when I receive traffic to this endpoint. So just a quick recap of what just happened. I added a print message inside this controller. I changed the return statement to an empty string. And so now when I visited the page, all that happened was I got a console message in my terminal. We probably don't want to do that, but we could. Right, so to wrap this example up, I'm just going to put some HTML as text. So this is an H1 element. And then a cool trick here, if you want to add more content, is you can just press enter and IntelliJ will add that plus mark. And I'll do a P. I'm going to refresh, reload the page. Cool, so we get hello something. And we have our HTML sort of like styling happening. We have our H1 here, then we have our paragraph here. So I'm going to pause here. I think it's a really good place to pause for questions. We just covered creating a basic controller and then responding with some HTML as a string. So I'm curious what questions you may have about this or anything else really. Yes. Right, so we have an HTML question basically wondering why did I need to put this in paragraph tags? Kind of get away without paragraph tags. I'm going to remove them and rerun it and just see if we have a visual difference. So I have to reload the page to see something different. And refreshing, it doesn't look that different at all. So paragraph tag didn't really impact the styling at all. I didn't need it, I guess. But yeah, one thing I do predict that you'll see with Studio this evening is that you'll be writing HTML in these strings. And it can be a bit hard to track what goes where. So it might be worthwhile like copying it into code editor for HTML and putting it back in, something like that. Cool. Other questions though about the controller, about anything related. Okay, no questions. How much does this feel? Kind of want to get a gauge for like how much does this feel like it makes sense versus like I hear what you're saying, my brain's not there yet. I don't know how to ask this question properly. This feels like a poll, but okay. So if you feel like super confident in what we've covered, can you raise your hand? Okay. If you feel totally lost, can you raise your hand? Okay. Thank you. Yeah. All right, cool. So I would say a small percentage of the room feels really confident. A couple people feel totally lost. Yeah, that's fair. Really, it's difficult to kind of cross through this territory since we just started here. It's a context switch. But yeah, feel free to ask questions. And don't worry about asking something that you think might be a silly or a dumb question. This is challenging material, honestly. Cool. So controllers behind the scenes, we sort of talked about this a little bit when we looked at the inspector tab for a website. So a website, when we go to a website in our browser, the browser makes a GET request, but then a bunch of stuff happens in the back end. There's all kinds of chatter happening back and forth that we don't really see all that network activity unless we like dig into the network tabs, like a hacker or something, or a developer, right? And a lot of that network traffic is just worth being aware of. And so if we go to youtube.com, it's going to load up the page, and then as soon as we click on a video or we hover over a video, it's going to be sending out requests behind the scene. It's going to be getting this data for us, the users. We won't necessarily have to worry about having anything as complicated or as complex as youtube.com, but it is sort of like you get the initial website and then it's just a ton of life activity behind the scenes. So an example of something that might be happening behind the scenes on a website, I found a public application interface. I think this would be better if I could, well, it's not very readable, but I think that's okay. So I just went to this website called API.something. And essentially you send them a zip code and they send you back data about that zip code. So I go change the zip code. This is a path variable for context. And so it's going to send me just some data about this zip code. And so this is data not intended for a user. You wouldn't consider this a website that a human would want to go to. This is rather data intended for an application to be able to fetch. And so here, yeah, so here is an API. Let me see here. There's a lot of stuff in here. Anyway, I don't need to try to understand this right now, but this is another example. It's from api.publicapis.org, and they provide this just for learning purposes. But yeah, this is just another example of like application data that's behind the scenes. And I make these examples because when we start getting into controllers with Java Spring, some of our controllers are going to return a view, something visual, HTML, stuff that we're used to. But some of them are going to handle data, kind of like that website I just showed. And so I guess as a teacher instructor, I kind of want to make sure there's a very clear distinction that we're doing both things with these applications that we're going to build. We're going to have a controller that does the visual side and then controllers that handle the data conversations. Cool. Questions on that? Clarifying questions? Anything? It's pretty quiet. Okay. So query strings and path variables. Check how I'm doing on time. We're doing good. Path variables. So you've heard me call them out a couple different times, but that's essentially where we have a URL and it's part of the path is a variable. And so in this example, 123 probably refers to the user ID. And so we can have multiple path variables in a URL, and this is an example of what that might look like. So we have users at ID 123 / orders, and then order with this ID. And the URL doesn't really have much data in it. We would need our Java application to look up who the user is by the ID and look up what the order is by the order ID. But we can pass that information in a URL. So this might be kind of hard to see because it's giant and it's squished on my screen. But here's an example of Java code to be able to parse those URL variables. So we can grab these path variables, and if you'll notice, we have normal, and then we have something new. We have @path variable, the name of the variable, and then we give it a type, and then the name. Then here we get the other path variable, the 4561, at ID, and then give it its type and name. So these path variable syntax, they work in tandem with our get mapping syntax. Inside our get mapping syntax, we will call out where the path variables are and give the path variables names. So you'll notice we have /users. Oops. You'll notice that we have /users right here, which maps to this /users. And then we have / and then a curly bracket, a name we come up with, another curly bracket. And that corresponds with this path variable, /orders. These are 1-to-1, / curly bracket, and then a name that we define which in this case we call order ID. And so that's how our path variable is able to know where in the path the variable is because we structured our get mapping like that. Okay, so right, so they're working together. Any questions on this process as far as or just path variables in general? Yes.
A bit more of a side, but like, let's say this happened in the Unix environment, would we be doing like backslashes instead of /slashes, or is this pretty universal regardless of environment?
Right. So the question was, if we're doing this in a Unix environment, would we care about the direction of the slashes? And so the quick answer is no. We don't have to worry about that. We're just going to follow the structure. When we're navigating like a Linux style terminal on like a Mac or a Linux, the commands and stuff, they're different. But that's at the operating system level, right? What this code here is going to be used for is not for navigating an operating system, but rather for working at the web level, at a web browser. And so this path right here is all after a URL. And so, we're not going to have to worry about the nuances between what operating system it's on. The only time that might come up, it has to do with how your Java SDK is configured. Is it going to compile down to something using, designed for Linux or not? But thanks for the question. Yeah, interesting. Cool. Other questions? No. All right. We'll move on. So the other thing we have, the other way we can sort of shove data into a URL is by using query strings. And these look ugly the first time you see them, in my opinion, but they're very useful. And so a query string is basically a set of key value pairs, kind of like an object. And so they're used very often. A query string doesn't start with a forward slash. Notice that. Instead, it starts with a question mark. And then after that, we have our first key separated with an equal sign. Then we have our first value. So the key ID maps to the value 1, 2, 3. And if we want to add another query string like key value pair, we need to separate it with an and symbol, and then we can add order equals 4, 5, 6. If we want to add another one, another and symbol, and then so forth. And you keep adding and symbols to add more of these to our query string. And then let's say we have a query string. How do we access the items in it? Well, we can see we don't have any special syntax instead of get mapping. It just ends at /user, just like this URL does. But inside of our method right here, we have something called request param. And inside request param, we just reference the ID, the name of the key in the key value pair. So here we have path variable for path variables. Here we have request parameter for request parameters, or for query string keys. Cool. So that's it for query strings and path variables. Last call for any questions about this, or questions about query strings, since we haven't done questions for that yet. Yes?
So if those do the same thing, when would you do one versus the other, or does it matter?
Right. Okay, that's a good question. So if a path variable and a query string similarly allow us to shove data in a URL, why would you choose one over the other? Very good question. So an advantage of the path variable is that it is very structured, meaning that if we wanted to basically get all the information about a particular user, it's going to be users / the user ID. And then if we wanted to, at this point, up until here, that URL is going to return a single user. From there, we can structure it so we can say user / orders. And so now we're trying to access the user's orders. But maybe they have multiple orders, and so then we're going to select one of them. And so this is like a consistent, like structured way to build a URL that's very good for if we had something like a nested object, that we were trying to drill down to. This query string, you can use it with path variables. It doesn't matter if you use them separate or together. This query string would be like, this is really good for, I would say general use cases. So if you just needed to add any data onto this endpoint without changing the endpoint, but onto this endpoint right here, you can add just key value pairs to it. So I would say, in my opinion, this is like universal add data into the request. This is more thought out because you're actually changing the URL to sort of be how you access the data. And so the actual shape of the URL corresponds with the data versus I'm just adding data onto a URL. It's subjective, and honestly, you could design it either way. But I would say that, yeah, I see it both ways. Cool. Thank you for the question. Any other questions over here? No. Okay. Annotations, we are not going to spend much time on this. This is more of a reference. So we know about annotations. We've seen them show up before. The new important ones for controllers in Java Spring are request mapping. And so this is an all-purpose controller annotation. For me, when I was learning Java controllers, this tripped me up just a little bit. And the reason why it tripped me up a little bit is because I saw it being used one way, and I thought in my head, oh, that's what request mapping is for. It's used for, you can either make it a post method or a get method or both. And so that's what request mapping is for. Request mapping is pretty general purpose. There's like a couple different things you can do with it. Generally speaking, you'll see it used at the class level to set the base path. And I'll show an example of that soon. So just know that request mapping can be used for different things. Get mapping is a lot more specific. Get mapping, you're going to use that on a specific method to say, this is a get endpoint for this path. Post mapping, like get mapping, very similar. Big difference between post and get is with a post request, you can send data in the body of the request, so not in the URL, but in something more behind the scenes. You can send data that way. Very useful. At controller, we saw this earlier. This basically says this class is a special class that can handle web traffic. If you see at rest controller, it's just like controller, but it adds behind the scenes, it adds response body to every method in that class. So if you remembered earlier, we had to add response body to the method. REST controller does that automatically. And so you only want to use REST controller if you knew that all of your methods would need the response body, and ideally if you knew it was to be a REST controller. Finally, we have request body. This is used to get the data included in the body of an HTTP request. So to get the data from a body of like a post request, we use this. Request param gets the query parameters from the URL, and path variable gets the path variable from the URL. Real quickly, design patterns. This is a bit of a reference here. So we have a REST controller. Let's see here. I'm going to show this in code real quick because I think that would be more effective. So I have a controller here, and its only purpose is to return data. I don't want it to return like any HTML. And so it's at controller. And so here, this method returns some random variables at the endpoint of, or at the path, like random / variables. Then I have my response body on there, allowing me to include the data in the response. And then this method will give a random number when you go to random / number. Then we have the response body, right? So we have this general way of making it. Alternatively, here's a refactored version. So here we have request mapping set the base path at / random. And so now this get mapping is still at random / variables. And this get mapping is still at random / number, but it has a base, it's set up here. So this is sort of refactored. And so we can see that this class handles traffic at random, at the random path. And then these kind of add on to it. You'll also notice that here, since I'm just dealing with returning data, I call this a REST controller, and so I no longer require my, I don't remember what it's called, response body annotation on these two methods. So I think we are probably, we're really close to time here. This is the extra content we actually went over earlier. Cool. So before we break for studio, any questions, comments, concerns, all of it? No? Looking forward to studio? Cool. I'll see y'all back here at 8 for studio.